Welcome. Today, we are diving deep into coding your computer. You see all these acronyms, CPU, RAM, SSD, and it can feel a little bit like alphabet soup. So we're going to pull back the curtain on the core components that power your digital life, and we'll turn all those complex terms into simple, easy-to-understand ideas.
It seems so simple, doesn't it? You just press a button and, well, magic happens. Your screen lights up. But behind that one single click, there's this incredible, perfectly choreographed sequence of events. We're going to follow that journey from a totally lifeless machine to a fully functioning portal to the entire digital universe.
And it all starts with just a single spark of electricity. Before your computer can do anything else, before it can even think, one tiny, fundamental program has to give the whole system its wake-up call.
That program is called the BIOS. The best way to think of it is like the computer's built-in alarm clock. It's a little piece of software that lives right on a chip on the motherboard, and its only job is to be the very first thing to wake up and make sure everybody else is ready for work. It does a quick health check on all your components.
So this whole process is a really clear four-step handoff. First, obviously, you hit the power. Second, the BIOS wakes up and does a quick test. Is the keyboard connected? Is the memory okay? Third, it hunts down your operating system on your main drive. And finally, and this is key, its job is done. It hands over complete control to the OS.
So the computer is officially awake. Now it's time to meet the real boss, the software that runs the entire show and actually lets you, the user, do stuff.
And that's the OS, or operating system. This is the part you're probably most familiar with. We're talking Microsoft Windows, or maybe Apple's Mac OS. It is the essential software that acts as the bridge, the translator, between you and all that complicated hardware humming away inside the box. Without it, you'd just be stuck.
A really great way to think about the OS is like the conductor of a symphony orchestra. It doesn't play an instrument itself, but it makes sure all the different sections, the processor, the memory, the printer, your mouse, that they all work together in perfect harmony. It is the master manager that makes it all seem seamless.
All right, now that our manager is in place, let's get to the core team. These are the components that do the actual thinking, working, and remembering. This is where all the action really happens. First up is the big one, the CPU, the central processing unit. This thing is the engine of your computer. Its power directly impacts how fast and snappy your machine feels, because it is responsible for doing all of the heavy lifting.
And yes, it's almost always called the brain of the computer, and for good reason. Every single calculation, every instruction, from opening a simple file to streaming a 4K movie, it all gets processed right here. And just like a real brain, a more powerful CPU means a faster, smarter, more capable machine.
Okay, next up we have RAM, or random access memory. Now, if the CPU is the brain, it needs a place to put down the things it's currently thinking about, right? Well, that place is the RAM. It's a super fast but temporary storage space for all the apps and data you have open right now.
I love this analogy. Think of RAM as your physical desk. If you have a tiny little desk, it gets cluttered really fast, and that slows you down. But if you have a huge, sprawling desk, you can spread out multiple projects and switch between them instantly. That's exactly what having more RAM does for your computer. It gives you more space to multitask smoothly.
So here's the crucial difference to get your head around. It's the desk versus the filing cabinet. RAM is your desk. It's for what you're actively working on. But here's the catch. When you turn the power off, the desk gets completely cleared. Everything on it vanishes. That's why we call it volatile memory. The filing cabinet, on the other hand, is your permanent storage, where you put things for the long haul. So let's talk more about that filing cabinet, the permanent home for your operating system, all your programs, your photos, your documents. Today, this long-term storage pretty much comes in two main flavors.
On one side, you've got the hard disk drive, or HDD. This is kind of the old school tech. It has a physical spinning metal platter and a little arm that reads and writes data, almost like a tiny futuristic record player. On the other side, you've got the solid-state drive, or SSD. This is the modern stuff. No moving parts at all, just microchips. It's basically a massive, incredibly fast flash drive.
So why should you care about this? Well, because an SSD is just dramatically faster. And I'm not talking a little bit faster, I mean it is a total game changer. With an SSD, your computer can boot up in seconds. Seriously, like under 15 seconds, compared to a minute or more with an old hard drive. Your apps will launch almost instantly. It is the single biggest performance upgrade you can make to a computer.
Okay, so our computer is booted up, it's running programs at lightning speed, but it's not an island, right? How does it connect to the internet and talk to the billions of other devices out there?
Well, that is where the IP address comes in. IP stands for Internet Protocol, and it's basically a unique address that gets assigned to your device whenever it connects to a network. It is the fundamental building block that allows data to be sent to and from your specific computer across the entire internet.
The P.O. Box is just a perfect analogy for this. When you go online, your computer gets a temporary mailing address. This is what allows the internet to deliver that website you requested or that email from your boss directly to your screen. It's how the global network makes sure the right information gets to the right device.
All right, let's do a quick recap of this whole incredible journey. We've gone from a single, simple button press all the way to surfing the entire web.
When you think about it, it really is like a highly efficient team. You've got the BIOS, who's the first one in, turning on the lights. Then the OS comes in as the project manager. The CPU is the brilliant mind doing all the thinking, and the RAM is the workbench where all the active work happens. The SSD is the team's library or filing cabinet, and the IP address is their mailbox connecting them to the outside world. Every single part has a critical job to do.
And what's really amazing is that all of these complex parts and processes work together totally seamlessly, thousands of times a second, to create the simple, intuitive experience that we all just take for granted every day. The journey of just one single click is truly a modern marvel of engineering.
So next time you power on your phone or your laptop, you'll know about the incredible team working behind the scenes for you. And it leaves us with one final thought. We've come this far, from simple machines to these interconnected digital brains. What's next? What kind of problems will the computer brain of the future be able to solve?